is joining two metals with electricity. This system has advantages and disadvantages. The advantages is that it is very cheap, the equipment that is used to arc welding, and also transporting this type of equipment is very easy. Also, the process can be completed with rain or with wind, so it is very easy. But the disadvantages is that it depends on the operator that is arc welding, on its ability. Also, it produces more waste, so it is less efficiency, and at the end the project can be more expensive. It can be thought to use in thin metals.
After you weld two plates of metals, the structural changes that you can expect are that in the in-between zone, you will have the metal which you weld, and the side areas the grain will course, and that is the cause of that the metals lose properties, mechanical properties. And after that coarse zone, you will find a fine grain zone that will be will be before the cold area of that metals, and that's why the in-between zone will be very strong after welding, but the next area will be very weak. That's the structural changes you can expect before, I said, after welding.
For the results, we can analyze that the welding samples have a significant change in mechanical properties. For example, we can see that it increases the hardness, and also it can increase the voltage. But by the other way, we can see that it decreases the tensile strain, yield strength, and also the impact coldness.
Arc welding is a process that applies two metals to and applying heat and connect them with it gets the name the arc welding. So how this is worked with the coated welding. It works about putting an electrode, a coated cable that are from the energy where you take the energy. The work is the sample that you use it for connected, and the electrodes goes in the manual electrode. So you connect a cable to the work and a coated cable to the electrode, and put it in the welding zone. So where the energy is going to be, the heat it will be by the work and the electrode, and this result they are welding.
And now we do a metallography practice to check the grain of the size of the welding sample and the normal sample. We obtain as a result these pictures, and we can analyze that we have a decrease in the welding sample, and this have an impact on the mechanical properties. So the grain size decrease and the number of grains increase. As engineers, we can see that welding is a process so used in industry, and in this laboratory we analyze how the mechanical properties change of a welding sample and non-welding sample. We study these behaviors, and as engineers it corresponds to us select what we want to create something.
For me, this practice was very interesting since the part that we weld the two metals up to the part we make a mechanical study of the welding part and a normal metal. I think it's very important to consider this change when you weld two metals, because there you can have there you can have a disadvantage that can affect the function of your or the application of your metal.
My personal opinion, this is very important to know for an engineer, because like a common person who is not an engineer may expect that welding will increase the mechanical properties of a material, but in reality this is not. This is not, because if you made a piece with a lot of welding cords, it will be very weak. And like mechanical engineers, it's a very values knowledge to me.
In my personal opinion, this practice is very useful for the future, because many processes in the industry is used arc welding. So it's very important to know how it is affect the properties of the material. Also, for common persons or persons that are not familiar with this topic, doesn't know that the welding could produce a flow in the material. So this could be very important to know, because it affects the material that we use.